Hi everyone, this is Navika Chawda, a cloud engineer, Microsoft most valuable professional, and a LinkedIn top voice in cloud computing. I warmly welcome each one of you to the 15th episode of Tech Chat with Navika, wherein today we would be discussing about a very interesting topic, that is infrastructure as code. And to share some more expertise, we have an expert with us today, Mr. Eduard. Eduard is a Microsoft most valuable professional in Azure category. Having more than 20 plus years of experience in the IT industry, he is currently working as a cloud solutions architect and a team lead at 4DotNet. He is also an international speaker and the founder of .NET Friday. He is extremely passionate about sharing his knowledge with the tech community. His areas of expertise lies in C Sharp, Azure Devops, IAC, Angular, and the list goes on. Thank you so much, Eduard, for taking out your precious time and joining me in today.
I think it's the first time that I've had such an awesome introduction. So thank you for that.
You're most welcome. My pleasure. All right, then let's get started.
All right.
Great. So, as we talk about a well optimized infrastructure in cloud, right? It is very
Yes.
important to have a proper automation in place, which helps in the delivery and the deploying of infrastructure, which henceforth is consistent and efficient. Now, as we talk about infrastructure and the automation and the consistency in it, that is where infrastructure as code comes into the picture. So, to get started with it, can you please explain as to what infrastructure as code is all about?
Sure. Well, it's already a little bit in the name. So it's quite obvious to say that infrastructure as code basically means that you describe your infrastructure as code. And there are several ways to do that and several technologies to do that. And I'm a Microsoft MVP and I really like to work with Azure. And the native way of doing it in the Azure way is using ARM templates or maybe the newer version called Bicep. But you're not limited to that. You can use different technologies to do so. And the idea is that when you have a piece of software and you want to deploy that to a cloud environment, then it's obvious that your software is going to evolve over time. You're going to add stuff. You maybe need a different database or a different storage mechanism. And to get it all working in your cloud environment, you have to click all these resources together and tie them together for the system to be able to communicate with these systems. With infrastructure as code, you have an additional code base describing the infrastructure of your system. So if your software system evolves over time, you can also make your cloud infrastructure evolve over time by just changing that code. And when you then make a deployment, you first going to make changes to your infrastructure in the cloud, and then you deploy your software system on it. Does it make sense?
Of course it does. Of course it does. It's like usual. It's all about the removal of manual intervention. Like not
Sure.
100%, but at least to some great extent, right?
Yes.
Yeah.
Yeah. It is. Um, I think it is most important to have know people able to access your production environment.
Correct.
So, if you have data in production and someone can access that data, whether or not it's on purpose, he can manipulate that data, and that's a situation that you simply don't want. You want an automated process to do so, and that gives you a couple of advantages. So, if you do infrastructure as code, you basically remove configuration drifts. Because if you and I are going to configure a cloud environment and set it all done and make the situation that your software system works properly, and then do it again for a different environment. So let's say that that's for the test environment, and now you're going to create the production environment. You will make slightly different changes, causing that the test environment and the production environment are not actually equal. With infrastructure as code, you have this single uh, um, description of what you want your infrastructure to look like, and you simply deploy it twice, once to your test environment and once to your production environments, making them exactly equal. So that's one very powerful tool, and it also allows you to deploy your production environment in an automated way, and enables you to shut down access for people, for human.
Yeah.
And that's a big pro. And obviously, we also know this DTAP environment, right? You have a development, and then you
Yeah.
promote to test, acceptance, and
Right.
production.
Yeah.
But what if you have more test environments? So, for example, if you want to test certain features, so let's say that you're a developer and you want to create a new feature. If you use Git for your code repository, for example, you would create a branch, make your changes there, and then push those changes to that branch. And with infrastructure as code, you can now deploy that environment to a branch specific set of resources in Azure, test it in Azure, and when you're done, you complete the pull request and you remove the entire cloud environment. So that's one of the advantages. And what I typically do, if you have this dev environment in the cloud, I allow all the people to access that. So all developers are able to access the dev environment, and they can deploy and play about with the entire environment. But
Yeah.
from test on up until production, we shut access to those resources down. Um, and for example, use PIM, that's Privileged Identity Management,
Privileged identity
to
management.
yeah, exactly. To control who can access those environments in case of emergency. Let's say emergency.
Hmm.
It's cool word.
Hmm.
So I think those are the most important key points why you want to move to infrastructure as code compared to what we now call ClickOps.
That's right. That's right. In fact, my next question was actually to ask the benefits of using IAC, but your detailed answer already covered that. So we have already understood the what and the why part of IAC. Um, Now, if you see like DevOps and IAC are pretty much related to each other, right? In a way, you
Sure.
can say that IAC basically sort of enhances the productivity of DevOps. We can say it in
Mhm.
a way, right? But still, I would like to take this as a separate question that how does IAC, like what role does IAC plays in DevOps?
Yeah, well, I already explained it a little bit at the beginning
Mhm.
of this podcast. I think the only way that you can complete are you familiar with this DevOps cycle, this 8 figure, in
Yeah.
which you go ahead and plan and develop, and it used to be
Hmm.
a circle. You plan and develop your stuff, and
Yeah,
then you
yeah.
deploy it.
Testing
But
and
now
that.
since DevOps, yeah,
Yeah.
but now since DevOps, it is this 8 figure, and that is because DevOps is basically where development and operations come together.
Yeah.
And you can only complete this DevOps cycle if you have your infrastructure written as
Hmm.
code and automate that.
Hmm.
Um, because else it would be manual labor.
Hmm.
And here again, infrastructure plays an important role, or infrastructure as code plays an important role, because if your infrastructure code lives right next to your software system code and you
Hmm.
deploy it, they are both versioned the same. So
Yeah.
if you make changes to your software that require changes in your infrastructure, you can deploy that in one go,
Hmm.
and then doing DevOps with, for example, Azure DevOps or maybe GitHub Actions. You
Hmm.
can deploy your infrastructure or the new version of your infrastructure just prior before you deploy your software system. And um, I think the best part is in rolling back. So let's say
Hmm.
that you accidentally created a bug in your system and you want to roll back to the previous version. You can simply do that with Azure DevOps or GitHub. You can pick a previous version of your code and
Hmm.
deploy that. But by doing so, you will also revert the version of your infrastructure back to the previous version. making sure that you don't introduce any breaking changes by only reverting the software system back to the previous version. So
Hmm.
I think DevOps is really important when you do infrastructure as code, and even more because a DevOps pipeline or a GitHub action is an automated system that you can give an identity in Azure and allow that identity to do this infrastructure and resource provisioning, and then again, instead of letting some human do it, with the potential errors that come into play when he does so.
That's right. That's right. It's we can say in a way that DevOps and IAC sort of go in hand, or it complements it. And I think even in
Yeah.
the case of cloud architects as well, right? Like the cloud operations team also, right? It plays
Hmm.
a similar important role in that front as well. If we talk about IAC, it's like entire infrastructure in place at the first time, at the
Yeah.
first place. It's just all about
Yeah.
making changes just in a few of the files, right, and then deploying it in one go instead of going onto the, let's suppose, Azure portal and then creating manually each resource and then integrating it
Hmm.
with each other. So it's like just one click and everything gets deployed. So it sort of
Yeah.
just ends up saving so much of time as well, even if you see from the perspective of cloud operations.
Yeah, so you in Azure you have four different levels of structuring your resources. The first level would be tenant. Then
Yeah.
you have management groups and subscriptions, and then finally your resource groups.
Right.
And all those four levels can be targeted with doing infrastructure as code deployments. So when you have a piece of code that represents an infrastructure, you can target your tenant and create resource groups from there, and even add policies to them.
Correct.
And then you can assign subscriptions to the management groups and assign policies to those. So for if you even if you don't if you're not a software developer, if you're really into ops and creating the entire cloud environment, creating this environment in a way that is compliant to your company is really doable and automatable with infrastructure as code. So it's not only the developers that we're targeting here, it's the entire company or the entire IT operation in your company that can take advantage of infrastructure as code.
That is right. Absolutely. I second your point. Um, if if you can just explain a little bit working of IAC. I know you've already given a lot of detailing, but if you can just talk a little bit about different phases of IAC, I mean, I would love to hear that from you.
All right. So in Azure, there is a mechanism called the ARM, or the Azure Resource Manager, and that is the one mechanism that is responsible for provisioning resources in Azure.
Yeah.
And if you have an infrastructure as code template and you want to create a deployment of that, then the first thing that you would do is send that template to the ARM, and the ARM will go ahead and validate whether or not the template is valid, yes or no. And then it will go and do basically what we call an incremental change on your infrastructure.
Correct.
And it is important to understand that you cannot rename resources because the ARM tries to recognize resources by name. And if you change the name, it just recognizes the resource as a new resource. So let's say, for example, that you want to create a storage account and you have a template that contains a storage account. You provision that to the ARM, and the ARM will validate that template. And once it's good, it will it will look at your current infrastructure. So what is already there in your cloud environment, and it will try to identify changes in the current cloud environment and the template that you just submitted. And if there are changes, it will send instructions to what is called a resource provider. So each and every different resource type has its own resource provider. So for a storage account, there's a storage account resource provider. And for, I don't know, a SQL Server, there's a SQL Server resource provider. And the ARM will send out an instruction to the resource provider to change that storage account to whatever you described in your template. And that resource provider will then get back to the ARM, report whether or not the operation was successful, and the ARM will then tell you, okay, now whenever your all the resources that you described in your template are completed, tell whether or not the entire process went successful or not, and if not, come with some errors.
That's right.
Now you can drive. Sorry. And now you can drive this ARM with a template that's called an ARM template, which is basically a huge JSON file. And the first versions of working with infrastructure as code natively for Azure was working with ARM templates.
Yeah.
And it's important to understand that today the ARM is driven by ARM templates. But writing and maintaining ARM templates is somewhat hard because you have to comply to the ceremony that comes with JSON. So there was a team, I think today around 2.5 or 3 years ago, that found these ARM templates were, not optimal to work with, and came up with a different solution. And that is what we now know as Bicep. It's actually a wordplay because we have the ARM, the arm, and the bicep is the strongest muscle on your arm.
I never thought of that, right?
It's actually a wordplay.
And
bicep is a way of describing your desired infrastructure, just in a different way. But in the end, when you make a deployment of your bicep file, under the hood, the ARM will transpile that template to an ARM template and execute that. And that is important to understand, because if you receive errors, you will probably receive an error telling you, okay, something went wrong on ARM template line 365. But that is not the line number of your bicep file. That is the line number of your ARM template. So you need to understand that it's actually the ARM template that works on it. But having said that, that is all you need to know about ARM templates, because really Bicep is a relief, and it's very fun to work with. And it is the first time I had experiences writing infrastructure as code that worked in one go without problems. So but having said that, I now refer to ARM templates and Bicep, and those are not the only parties that play in this infrastructure as code realm. There's more. For example, if you really want to describe your infrastructure as code with the language that's familiar to you, let's say that's C#, you can do so. There's a tool called Pulumi. You can use Pulumi to describe your infrastructure using C#, and Pulumi can take that and drive your cloud environment from there. And I think the most famous one is Terraform. Actually, Terraform and Bicep have a quite similar syntax. It's not exactly the same, but it's somewhat similar. And Terraform has a couple of pros and cons compared to Bicep. For example, Terraform can target multiple platforms, while Bicep at this time is only able to drive Azure resources. If you have a multi-cloud environment and you want to target AWS as well, for example, you can do so using Terraform. On the other hand, Terraform keeps a local state, while, for example, Bicep templates always compares the changes, or at least the template that you submitted to the ARM with the infrastructure that is actually there in your cloud environment, which may be of an advantage. So it's important to know that there are what we like to say multiple roads that lead to Rome. Which basically means there's not one solution. There's a couple of that you can pick from, and
Right.
all have their pros and cons. So yeah, it's a good idea to
Yeah,
investigate
that's
before you start.
yeah, and that's true. But like it's like I think since IEC makes our job pretty easy, I think created it like at the first place, and I think maintenance is not that much tough
Yeah.
because then you just have to do certain things like changing the parameters and all. And even if we talk
Hmm.
about ARM templates, it just follows a declarative syntax, right? So you really don't have to
Yeah.
code it also.
No.
It's just one line arm exclamation and you will get something, out there
Yeah.
and then you just have your resource. So I think it's pretty easy. So even someone who hasn't actually tried it, it's pretty much easy.
Yeah. Yeah.
Yeah.
And by the way, if I always transpile my bicep files to JSON to ARM templates in my pipeline,
Hmm.
and then publish those as pipeline artifacts and deploy those. But you don't have to. You can immediately send your bicep files to
Yeah, yeah.
the ARM. But then again, if you're in the portal, you receive an error, you can
Hmm.
review the ARM template that is actually executed to there find the line number where the error
Hmm.
where something went wrong.
Correct.
So, so that would be helpful to find the problem.
That is right. Now we've understood a lot about IAC, but I think it would be good to know that what are certain best practices that one should keep in mind while implementing IAC at the first place. So, any top two or top three practices if you would like to share?
Yeah. Okay. So best practices for infrastructure as code is really hard because every
Hmm.
desired cloud infrastructure has their own needs. So it's really hard to say, okay, you need to do it this way, then you're good, or you need to do it that way, then you're good. But I would also I would always recommend people to come up with a certain naming strategy.
Hmm.
But that's regardless of using infrastructure as code.
Yeah.
But make sure that you name your resources well, and by using infrastructure, you can somewhat demand doing so.
Hmm.
So that is one. It is also a good idea to investigate for yourself whether or not the infrastructure as code templates should live in the same code repository as your software system code or not. For
Yeah.
example, if you have an if you are an IT operation and you want to create this very popular hub and spoke network topology, you need to have a hub before spokes can attach to the hub.
Yeah.
And it would be a good idea for this hub to have a separate code repository for the infrastructure as code for the entire hub, and
Hmm.
then have the software system that represent the spoke have those repositories also contain the programming code and the infrastructure as code. So
Hmm.
that is also one to keep in mind. You need to make big decisions whether or not your infrastructure as code lives right next to your software system or not.
Yeah.
If you have struggles with finding what's actually in your infrastructure as code template, you can use tools like ARMViz, or it's even in the portal at this time. You can upload your infrastructure as code template and see in some um, charting way what is actually there and what relations the resources have to one another.
Yeah. That's right. And as you said, like naming convention is very important. I think that's one very important point which you mentioned about. And also, I think one more, if I were to add on, was like it can be maybe, making your parameters as much as dynamic as possible in a way that you don't have to sort of always get into the code. Every time you want to deploy an infrastructure, you don't have to actually get into the ARM templates and make the changes.
Yep,
It's like just doing it one place, and then that is sort of
yep,
read with each of the ARM
yep.
template.
So what you can do with Bicep is there are two, I believe, the most important keywords. One keyword is a resource, and that means that you want to create a resource. And then you go ahead and describe what resource you want to create and what properties it should have. The other keyword is a module. And with a module, you actually refer to a different bicep template. And that
Okay.
allows you to, for example, if you have an environment with multiple websites, and you want those websites to be deployed in the same way, you can
Mhm.
create one bicep template and deploy
Mhm.
that over and over and over again as a
Mhm.
module. And to take that one step further, you can even publish this bicep template to a container registry,
Mhm.
which is a container registry that you may recognize from working with containers. For example, if you have AKS cluster or Azure Container Apps,
Mhm.
then you need to deploy your containers to container registry, and you can use this exact same container registry to publish your bicep templates to. And that
Mhm.
allows you to share those templates across your entire organization. And that again is as an ops department being responsible for the resources that are provisioned in your cloud environment, you can now take control of what type of resources you want to present by default
Mhm.
with these templates, and then make those templates compliant and tell the teams, okay, if you now want to deploy this resource, then you need to take advantage of the template that we pre-deployed for you in this container registry, because then
Mhm.
we're sure that it's compliant, and
Mhm.
else you have to do it on your own.
That's right. That is correct. Thank you so much for such a detailed answer. Uh, I think we have all the information till now. What, why, how, and we've literally checked all these different factors of getting to know IAC. And now, as we
Yeah.
are heading towards the end of the podcast, the last question that I would like to take up is any best IAC tools that you would like to recommend to people to explore if they haven't yet?
Um, I think, oh, this is an easy one. I think that Visual Studio Code is the number one tool that I use for writing infrastructure as code. It is
Same.
wonderful. You can add an extension called Bicep, and with this extension, it is really hard to make mistakes, because it will like the IntelliSense when writing C sharp, it will immediately tell you upfront what errors you made, and how to maybe even how to fix it. So I think when writing infrastructure as code, that is my number one tool.
That's right. It's pretty much easy and simple to use as well. Not much of configuration needed as such.
Yeah, and it's installable on all the platforms that we know. So whether
Yeah,
or not you're using Mac, Linux, whatnot, you can take advantage of Visual Studio Code and use that.
that is absolutely right. All right. We have reached towards the end of the podcast. Thank you so much, Edward, for taking out your precious time. It was such an informative and educative podcast. And
Good to hear.
this was a topic that even I actually love to talk about. So it was more like a conversation today, and it was just an add-on to my knowledge as well. So thank you so much once again for gracing the podcast. And would you like to give any signing off note?
Well, first I want to thank you for having me. And if you have any other questions writing infrastructure as code, you can reach me on LinkedIn or whatnot. And if you're really interested, I have written a book together with Henry Bain and Erwin Staal, and it's called Azure Infrastructure as Code, and you can get it on Amazon. And that will really tell you all the ins and outs that you need to know about infrastructure as code.
True that. It was my pleasure having you, and I'm already going to buy your book as we already had a chat before. So one buyer is already there. All right.
Cool.
Thank you so much once again, Edward.
Yeah, thank you too, and you have a great day.